Right, so we can represent angles now on our xy coordinate plane, which is good, and what we're going to do now is think about how that relates to our trigonometric ratios. This doesn't work particularly well. Right, so let's draw those axes again. Right, so here are our axes, and before we start considering sine, cos and tan on here, we're going to draw a circle. Not a very good circle, but there we go. This circle has a radius r up to that point on the circumference. It is making an angle of theta, and if we consider that point P on the circumference, it has an x coordinate and a y coordinate. Okay, so the x coordinate is across there, and the y coordinate is up there, and you can see we can make a right angle triangle out of all of that. So if we're thinking about sine, cos and tan, we can express sine, cos and tan in terms of the x coordinate, the y coordinate or the radius. So very quickly we could write sine theta as opposite over hypotenuse, or y over r, cos theta as adjacent over hypotenuse, so x over r. I'm trying to write it horizontally here. Mr. Rattigan suggested that was a good idea. Tan theta is going to be opposite over adjacent. Okay, so there are our ratios. That's so far so good. Now, what we can do here when we're thinking about the trig ratios is thinking about when they're positive and when they're negative. So for what values of theta is sine going to be positive and is sine going to be negative? Okay, so if we consider this point P being in our first quadrant, so this is our first quadrant here, between 0 and 90 degrees. The x-coordinate is going to be positive, the y-coordinate is positive, the radius is always positive. So when we look at sine, we're going to have something that's positive divided by something that's positive. Okay, so the overall effect of that is that it's going to be positive. If we look at cos, the same thing's true. X-coordinate is positive, the radius is positive, so cos between 0 and 90 is going to be positive. And with tan, y is positive, x is positive, therefore the whole thing is positive. And if you look at your trig graphs between 0 and 90, then that makes sense. They're above the x-axis, they're all positive. So what we can say is that any of those functions is positive in the first quadrant. What about if we have a look in the second quadrant? So we call this the second quadrant. So between 90 and 180 degrees. So if we have another point now, another point P, we have a radius here. We've now got our x-coordinate is this one, our y-coordinate is this one. Okay, and we can start considering the signs of the functions in that second quadrant. Okay, so if we're thinking about it in the second quadrant, then first of all, starting with sine, being a little bit naughty here, but let's just call, for simplicity, let's just call that theta. Okay, so looking with this theta, sine is opposite over hypotenuse. Both those things are still positive. The y-coordinate is still positive at this point here, because it's above the x-axis, and r is always positive. So sine in that second quadrant is positive. Okay, now if we think about cos is adjacent over hypotenuse, so what we've got here is that x is going to be negative. So we're going to have something negative divided by something positive. That's going to give us a negative value. Okay, so what we're talking about there is that cos of an angle between 90 and 180 will be a negative number. And again, if you look at your graph of cos theta, that's where it ducks under the x-axis. So from 90 it goes negative. Okay, and that's what we're showing here as well. And tan also, tan is opposite over adjacent, so one of those things here, the x is negative, so tan is going to end up being negative. So in summary, so far we've got that all of the functions are positive in that first quadrant, but in the second quadrant only sine, so s for sine, is positive. Okay, and what we do is work our way around all the other quadrants. So now if we look at the third quadrant, in the third quadrant both x and y are going to be negative. Okay, because it's to the left and it's down, both x and y are going to be negative. So sine is going to be negative. Remember, r stays positive. So for this point here where y is negative, we've got negative divided by positive. That's going to be negative. For this point here, x is negative, r remains positive, but it's negative divided by positive, so that's going to be negative. But then with tan, we've said that x and y are both negative, so a negative divided by a negative is going to give us a positive. Okay, so in this quadrant, so just recap what we're saying that this third quadrant here, so between 180 and 270, sine of any angle between 180 and 270 will give us a negative. Cos of any angle between 180 and 270 will give us a negative, but tan of any angle between 180 and 270 will give us a positive. So we can write T for tan. And then by a similar sort of analysis, if we pick a point in the fourth quadrant, so between 270 and 360, now we've got that x is positive, because we're this side of the axis, x is going to be positive, but we're underneath the x-axis, so y is negative. Okay, so now if we go through and figure out what we've got, so I'll tell you what, why don't we put that here, that would be a good idea. So x is positive here, y is negative, and r is positive. So looking at sine, we've got negative over positive, sine is going to be negative. For cos, we've got positive over positive, x divided by r, so that's going to be positive. And for tan, we've got negative over positive, so that's negative. So again, in summary, the only one that's positive in this fourth quadrant is cos. Okay, so we can summarise all of that by just looking at these letters that we've put in each quadrant. A tells us that all of the functions are positive between 0 and 90. S tells us that only sine is positive between 90 and 180. T tells us that only tan is positive between 180 and 270. And C tells us that only cos is positive between 270 and 360. Okay, that's a really important thing to remember. There are various ways to remember that. I remember it as all students take calculus. That's one way of doing it. Last year, my Year 12 class came up with all seagulls take chips. So you might want to use something like that. Whatever you like, I don't really care. As long as you remember the order of A, S, T, C. Okay, and so where each of the functions are positive. Okay, we're going to keep going and look at a couple of applications of this now, and a couple of examples, the type of thing that you're going to have to do. Okay, so the first, an example question is to represent something along the lines of sine minus 100 as a sine of an acute angle. Okay, so representing that as sine of an acute angle. So the first thing we do is we look at the angle that we're looking at, so minus 100. Hopefully from the previous video you're okay with that idea. So this angle of 100 is measured anti-clockwise this time, because it's minus, around from the positive x-axis. So we have a solution that's represented by, I don't mean a solution, but we have 100 degrees represented by that line there, which makes an angle with the x-axis of, now let's get this right, we've gone 90 to here, then another 10 to there, so we've got another 80 to get round to that point. So that's 80 degrees. Okay, so we can say that sine of, ignoring the signs at the moment, sine of minus 100 is going to have the same value as sine 80. Okay, but then the question is it plus sine 80 or is it minus sine 80? So then we look at these four letters and use that to help us figure out whether it's going to be positive or negative. And because we've represented this angle of minus 100 degrees in the third quadrant, where only tan is positive, that means that sine must be negative. Okay, we'll do a couple more of those, but the bottom line, sine minus 100 is the same as minus sine 80. Okay, it's all about this acute angle made with the x-axis when we're doing this technique. That is fundamental to dealing with trigonometric problems using this approach, using this ASTC approach. It's all about figuring out what is the acute angle made with the x-axis for the particular angle that we're given. Okay, let's have a look at another one. Let's have a look at cos of 330. How we would represent that using an acute angle, just like we did here. Excuse me. We found the acute angle that was equivalent to minus 100. Okay, so firstly we need to represent it with a line on our coordinate system. It's starting to get a bit messy in here now. So 330 degrees, we start here, it's positive, so we go almost all the way around. Stop using a ruler. And we get to there. So 330 degrees clockwise all the way around to there. That leaves us with an angle of 30 degrees there. Okay, that's our acute angle. It's the acute angle with the x-axis. Okay, so we can say that that's the same as cos 30. Now we have to consider the sine. So we've drawn our line in the region for cos, for C, so that means that cos is positive in that, so we can just leave it be. Cos 330 is the same as cos 30. You can check that on your graphs if you like. Okay, let's do one final one. Let's do a tan. Let's do tan 500. Okay, so first things first, we need to represent that line of 500 on our coordinate system. So we go round once to get to 360. 1.5 times would be 540, so it's not quite as much as that, but it's over here. So that would be 540. That's 500. So that must mean that that angle there is 40. Okay, that's our acute angle. So we're going to be dealing with tan 40. Now we have to consider whether it's going to be plus tan 40 or minus tan 40. So we look here, the letter is S, so only sine is positive in the second quadrant, so tan must be negative. Okay? And I think that's probably a good place to leave this. But what we've shown is, just in summary, is where each of the functions is positive around the coordinate axis. And we've used our understanding of being able to represent angles on this coordinate system, and using that thinking to identify what the acute angle is. So the important thing is the acute angle with the x-axis. Okay, hopefully you'll be able to do things like this now. 2 stages. First one, draw a line representing the angle. Second thing, considering the sign. Is it positive or negative in that quadrant? Okay, thank you.